Hello everyone, my name is Sakif, and in this video I'm going to be talking about stress testing solutions in competitive programming, particularly on Windows. Firstly, I'm going to explain the general concept of stress testing in competitive programming, and after that I'm going to explain how to do it on Windows. Before we get to the topic itself, I want you guys to imagine a scenario. Let's say you're in a contest and you're trying to solve a problem. So what you do here, you first read the problem statement, then check the sample input and output. And once you understand the problem, you try to come up with ideas to solve it, and then you code it up and then you submit it, right? But what do you do if apparently you get this instead? You get a wrong answer on some test case. There are a couple things you can do here. You can try to work on your ideas in more detail, or you can try to make up some small cases and see if your program produces the expected output or not. But another thing you can do is stress testing. So what is stress testing exactly? In competitive programming, it means testing our solution on a randomly generated test case many times, hoping at some point we made a test case that makes our solution fail. So visually, it will look like this. So we first generate this randomized test case, and then we test it on our solution. And we do this again and again and again until we get a test case that makes our solution gives the wrong answer. And once we're at that point, we can just take that test case and try to analyze where our program gets it wrong. But how do you generate this randomized test case? How do you decide if your program has given the correct or the wrong answer? We'll check the next slide. So what you first want to do is you want to make another program called gen.cpp. What this program does is it generates this randomized test case that we're going to be using for our stress testing later. So once we have the randomized test case, we can just run it on our solution and get the output of that. Now, how do you decide if this output that we have here is correct or not? What we can do is we can create another program called brute.cpp and run the same test case on that program and get the output of that as well. So what is this brute.cpp? This brute.cpp is the brute force solution for our problem. Now, why would we want to do this? Yeah, the brute force solution may be slow, but they're always correct if you code it properly. So what we can do is you can just run the same test case on this program, then get the output of that and just compare our solution's output to this output. If it matches, then it means that we get a correct answer on that specific test case, and if it doesn't, then we get a wrong answer. Okay, what we want to do is we check if they are different. If they are indeed different, then we get a wrong answer on that test case because as we have said before, the brute force solution is always correct, right? So we can just terminate, but if it's still the same, then we can just repeat the whole process and do all these things again. But as you can probably imagine, doing this whole thing manually would be tedious and very time wasting. So what we can do is we can create a script to automate this whole process. You guys can try making your own script, but I've made mine. And this video was actually supposed to be a guide on how to use that script. But I thought maybe I could explain the general concept first so that it generalizes to a wider audience so people can watch it. In case you guys want to use the same script, you can check it out in the description below in my GitHub repository. And this will be the guide on how to use it. Also, I want to mention that the text version is also available in the GitHub repository. So if you guys prefer that version instead, you can just read them there. Okay, here is the script in my GitHub repository. You can find it from the link down in the description below. Once you're here, you can just download the script and put it in your computer somewhere. I've put mine here in this folder, along with the 3 programs that we need: the solution.cpp, the brute.cpp, and then the gen.cpp, right? Okay, now that it's here, let's see what's actually inside it. It's a very simple script. So what it does, it first compile the 3 programs that we have, the solution, the brute, and then the gen.cpp. And then it does the actual stress test itself for some number of iterations that we're going to define ourselves when we use it. So it loops for that number of iteration, and if it finds a difference, then it breaks out and displays out the difference that it has found. And if after that number of iteration it doesn't find any difference for the 2 outputs that we get, it prints out this very happy statement that we have passed all the test cases. Okay, that's a script. Very simple, right? So let's actually try demonstrating it, yeah? Here I've picked this problem called balance substring. So here we are given a binary string, which is a string that consists of only zeros and ones. And our task here is to find the longest balanced substring. So what is a balanced substring? Balanced meaning that it has equal number of zeros and ones. So for example here, the answer would be 4, because the longest substring that is balanced is of length 4, which is this one, 1010, or you can pick this one as well. That's for the first sample case. For the second one, the answer would be 0, because the string consists of only ones, so we have no 0 to balance them out. That's why the answer is 0. Okay, so that's for the problem statement. How do you actually solve it? Of course, you cannot use the brute force approach, because n here is up to 100,000. So that would be too slow. We're gonna have to come up with something better than that. So when I did this problem after thinking for a while, I came up with this solution, and it works on both sample cases. Here, let me show you. Okay, here, I actually have it already here. Let's run it. See, the output is 4. It's also 4 here. If we run this, run the second one, it gives 0 output as well, right? And it's correct for the sample cases. Let's actually try submitting it. Problem B, submit this. Apparently I got a wrong answer on test case 12 right here, test case 12. So what did I do wrong? From my point of view, my approach is already correct. I don't see any holes in it. But I got a wrong answer on some test case, so I must did something wrong, right? So what did I do wrong? At first, I don't know. And I was too lazy to try to come up with a counter test myself. So what I did is this stress test technique, so that it can find a counter test for me and I don't have to do it myself. So what we need to do is we must prepare the brute force solution and then the randomized input generator, right? The gen.cpp and the brute force.cpp. And here the solution is simple. The brute force here is slow, so we cannot submit this, of course, but we can utilize this for the stress test itself. So the solution is simple. Just check for every possible substring and check if it's balanced or not. If it is indeed balanced, then we can just print out the length. If after checking every possible substring we don't find any that is balanced, then we can just print out 0. And then for the gen.cp, we can just match it with how it is written here. It first prints out the n and then the actual binary string itself. So here is the n. It is a random number between 1 and 5. Then it prints out the actual binary string itself. Also, the n here, I want to mention that you want to make it small enough so that when you find the counter test by doing the stress test itself, the counter test isn't too big, because if it's too big, then it's going to be hard to analyze. The smaller cases is easier to analyze, right? So why not make it that way? Okay, so we have all the 3 programs ready. Let's actually do the stress testing. So the stress script is over here. What we can do is we can just run it. We write the word stress here, and we put the number of tests, the number of maximum iteration that the stress test will do. Here I'm gonna put 100, meaning that the maximum iteration is 100. Yeah. So let's actually do it. First compile the 3 programs we have. Let's just wait. Take quite some time here. Just wait. Okay, on our second test case, we find a difference here, which is this test case. Apparently, our program gives the output 2, but the expected answer is 4. The brute force's output is 4. So what did you do wrong? Here, right? If we try running this test case here, we get the output 2, but apparently the answer is 4 because here, 0, 1, 0, 1, right? So what did you do wrong? So after analyzing this test case, apparently what I forgot is to add these 2 lines. And once we have those 2 lines, let's run it again. We get 4. Get a correct answer. Okay, just to make sure, just to be sure, let's run this test again. It will run the same. It will run a random test case 100 times on both of our programs and check if there's a difference. So far, we don't have any. Okay, for 100 random test case, apparently our solution, our original solution's output matches with the brute force one. So at this point, I think we can safely assume that our program is correct. So let's try submitting it. And we get accepted. Good. Okay, I think that's all for the script. If you find the video helpful, you may please consider leaving a like so that I know that you find the video helpful. That would be rewarding for me. Okay, I think that's all for the video. Thank you very much for watching, and I'll see you very soon. Peace.